Kia ora koutou. Welcome to this NCEA Science 1.1 video on pressure. We'll get straight into it. So what is pressure and what is the importance of it? Well, imagine if you had two knives and you were trying to cut a tomato. One knife was sharp and one knife was blunt, and you applied a force of 200 newtons to the knife in the downwards direction. Which knife would you prefer to use in order to cut the tomato? Well, I'm sure you would all give the answer that you would prefer to use a sharp knife. So in this video, we're looking at the importance of pressure. So this is where pressure comes in. So how would we explain why the sharp knife would be better at cutting the tomato than the blunt knife would? Well, a sharp knife will have less of a point than the blunt knife will. The blunt knife will have a greater surface area at the edge of it, whereas the sharp knife will have a lesser surface area. So if we imagine that we're applying 200 newtons of force on each knife, the sharp knife, that 200 newtons of force, will be applied to a smaller area on the tomato than it would with the blunt knife. So if you can imagine, if you're applying the same force to a smaller area, then you're going to end up with a better result. You're going to end up applying more pressure and you're more likely to cut through the tomato. So we'll have a look at the formula that relates to pressure. So it's effectively just what we've just said. So P, which is pressure, is equal to the force that is applied over a particular area. So this equation makes sense. So if you can imagine, we've got 200 newtons of force. If we had a really large number for area, let's say we had a unit of 1, we'll find out in a second what the units of area are. But if we had a unit of 1, then the force divided by 1, that would be 200, so the pressure would be 200 units of pressure. If the force was still 200 newtons and we had a much smaller area, so let's say we had 0.1 units of area and the force was still 200 newtons, we would have to, effectively we would be timesing 200 by 10, so we'd end up with 2,000 units of pressure. So as the area gets smaller, the pressure will increase, and as the area becomes greater, the pressure will decrease. So that's what this equation shows, is that there is a relationship between force and area. As the area is greater, for the same amount of force, the pressure will be less. So we'll go over what these symbols mean and what the units are for each one of them. So I've already alluded to it. So P equals pressure, and the units for pressure are newtons per meter squared. So when we say newtons per something, we'd need to put that negative sign, so to the power of negative 2. So we could equally write this as newtons and the slash to show it divided by meters squared. This is the far more common way that you will see it written. So newtons per meter squared. There is also another way of writing the units for pressure, and that is named after somebody. So these are pascals. So you could equally write, when you're doing your answer, you could equally write pascals or pascal. So if force, we've already come across that, force is measured in newtons. F equals force, units are newtons, which are shown by a capital N. And area, you might already be able to see by the units that we're using for pressure, but area is got a capital A, and the units are meters squared. So I'll show that using the pen so that I don't confuse anyone. So meters to the power of 2. So one thing to be careful of here is that area has the symbol of a capital A. Remember, we've come across acceleration before, which has a lowercase a. So it's really important that you use that capital A to show area, and that's meters squared. To put this into a formula triangle, this is the same as velocity equals distance divided by time, or acceleration equals change in velocity over change in time, where for both of those, you take the variable that's on the top of the divided by sign and put that on the top of the formula triangle. So I'll move across a little bit further here. So we'll draw the triangle. And we've got force, which is on the top. So force on the top. And underneath that, we're going to have pressure and acceleration. So if we're ever trying to find the force, then we would hold our finger over F, and then we'll end up with P times A on the bottom. Or if we were trying to find the area, then we would hold our finger over area, and that would equal F divided by P. So to do an example for this, we'll go straight into a past exam question. So this is question C. So they've already talked about a horse in this. This question was 1C of the 2016 exam. So a horse, each of the horse's hooves have an area of 44 centimeters squared. So they should always, in the exam, convert that to the units that we need to use for our calculations. So each hoof has has an area of 0.0044 meters squared. So the hoof, when it's standing in the sand, will sink. The hooves exert a pressure of 200,155 pascals. Calculate the weight of the horse. So for this one, we're wanting to calculate the weight. So remember, the weight is the force applied to an object because of the effect of gravity. So weight is a force. So we can put in this formula, what we're actually trying to calculate when we're calculating the weight is that we're trying to calculate the force. So this is what we're trying to work out here. So to find out which formula we're going to use, we would use this formula triangle. We would hold our finger over F, and then we'll end up with P times A. So the formula that we need to use for this question is F equals P times A. F equals P times A. Now we know the pressure, so that's great. So pressure equals 200,155. P equals 200,155. Now the area is a slightly trickier one. So the horse will be standing on the ground with all four hooves on the ground. We know the area of one hoof, so we need to find the total area that the horse is using, the total surface area of the ground that the horse is standing on. So we can't just use the area of one hoof, we need to times that by 4. So the area is going to equal, area equals 0.0044 times 4, because there are 4 hooves, 1, 2, 3, 4. And so that is going to equal 0.0176. And I should use units, so this is pascals, and this is meters squared. So we've now got both of the values of these variables here. So pressure is 200,155 pascals, area is 0.0176 meters squared. So we just need to times those two numbers together. So the force equals pressure times area, which is 3,522, 3,522, and then 0.726, 728 rather, and that is in newtons. So it's not important in this topic to be able to get the correct number of significant figures, but what you should do is, for future reference, is to take the least number of significant figures that you get given to you in the question, which is 2, and then use that in the answer. So here, to write this as 2 significant figures, we would take the 2 first value holding numbers, which would be the 3 and the 5, and then everything else we'll put as 0. So we could rewrite this answer as 3,500 newtons. And that's it. So thank you for watching. For more science videos, like and subscribe to this channel. See you next time.